Picture a small, velvet-lined box, its interior dimly lit by a single bulb. Inside rests a cat, calm and curious, curled in a bed of straw. Beside it is a vial of poison, a radioactive atom, and a Geiger counter rigged to shatter the vial if the atom decays. The setup is simple, yet the implications are profound. This is Schrödinger's cat, a thought experiment devised in 1935 by physicist Erwin Schrödinger to illustrate the absurdity of quantum mechanics. The paradox is this: until you open the box, the cat is simultaneously alive and dead. The radioactive atom exists in a superposition of decayed and undecayed states, and the cat's fate is entangled with it. Only when observed does the universe choose an outcome. The experiment is unsettling because it forces us to confront the fragility of reality. If a cat can be both alive and dead, what does that say about our existence? Is reality a fixed tapestry, or is it a probabilistic haze until we force it into clarity? Schrödinger's cat is not just about quantum physics. It is a mirror held to the nature of observation, consciousness, and the limits of human understanding. Explanation of the concept. At its core, Schrödinger's thought experiment is a metaphor for quantum superposition, a principle in quantum mechanics where particles exist in all possible states simultaneously until measured. The cat is a macroscopic analogy for this phenomenon. Here's how it works. 1. The radioactive atom. The atom has a 50% chance of decaying within an hour. In the quantum realm, it exists in a superposition of decayed and non-decayed states. 2. The poison vial. If the atom decays, the Geiger counter triggers a hammer to shatter the vial, releasing poison. 3. The cat. Until the box is opened, the cat is in a superposition of being both alive and dead. The act of observation collapses the wave function, forcing the atom, and thus the cat, into a definite state. Schrödinger intended to highlight the strangeness of applying quantum rules to everyday objects. In the quantum world, particles like electrons or photons exist in multiple states at once. For example, an electron orbiting a nucleus isn't in one place, but in a cloud of probabilities. Yet, when measured, it chooses a position. The cat's plight extrapolates this to the macroscopic scale, where the absurdity becomes visceral. The paradox arises from the Copenhagen interpretation of quantum mechanics, which posits that observation collapses the wave function. Critics argue this interpretation elevates consciousness to a central role in shaping reality, a notion Schrödinger himself found preposterous. Schrödinger's cat is more than a scientific curiosity. It is a philosophical and existential enigma that challenges our grasp of reality. 1. The role of observation. Does consciousness collapse the wave function, or is it merely a passive observer? This question has divided physicists and philosophers. Some argue that any interaction with the environment, not just human observation, causes collapse. Others suggest that consciousness is fundamental, blurring the line between observer and observed. 2. The many worlds interpretation. Proposed by Hugh Everett in 1957, this theory sidesteps collapse by suggesting that every quantum outcome branches into a new universe. In the cat's case, both alive and dead versions exist in separate realities. This aligns with the simulation hypothesis, segment 5, where every choice spawns new simulations. 3. Determinism versus probability. Classical physics assumes a deterministic universe. Given enough information, we could predict every event. Quantum mechanics introduces indeterminacy. Outcomes are probabilities. Schrödinger's cat underscores this shift. The cat's fate is not preordained, but emerges from the act of observation. 4. The illusion of certainty. The paradox reveals how fragile our sense of reality is. We assume the cat is either alive or dead, but until observed, it exists in a liminal state. This mirrors the ship of Theseus, segment 1, where identity is fluid, and the bootstrap paradox, segment 2, where causality loops. 5. Ethics and free will. If reality is probabilistic, does free will exist? Our choices might be like the cat's fate, superpositions of possibilities until acted upon. Or perhaps free will is an illusion, and our decisions are mere collapses of pre-existing probabilities. 6. The paradox of scale. Why does quantum superposition apply to particles, but not cats or humans? The quantum to classical transition remains unresolved. Some theories suggest that macroscopic objects decohere too quickly to maintain superposition. Others argue that consciousness itself is quantum, implying humans might exist in superpositions of thought and emotion. 7. the limits of human cognition. Our brains evolved to perceive a classical, deterministic world. Quantum mechanics feels alien because it defies intuition. Schrödinger's cat is a reminder that reality might operate on principles beyond our grasp. Much like the simulation hypothesis, segment 5, suggests a layered reality. 8. Art and philosophy. The paradox has inspired countless works of art and literature, from What the Bleep Do We Know? To novels like Life of Pi. It asks, what does it mean to exist? Is existence defined by observation, or does it persist in unseen dimensions? 9. The paradox of certainty. The experiment's name itself is a misnomer. Schrödinger never intended the cat to be taken literally. It was a critique of quantum theory's overreach. Yet, the metaphor persists, highlighting how easily we anthropomorphize scientific concepts to make them relatable. 10. Quantum computing and technology. Today, quantum computers leverage superposition to perform calculations exponentially faster than classical machines. The cat's paradox is no longer just theoretical, it is a blueprint for the future. Schrödinger's cat asks, is reality a matter of observation? The trolley problem asks a different question. Is morality a matter of observation? Imagine a trolley barreling toward 5 people tied to the tracks. You can pull a lever to divert it to a side track, where 1 person stands. Do you act or do nothing? The trolley problem is an ethical paradox, where the calculus of life and death becomes a numbers game. Like Schrödinger's cat, it forces us to confront uncertainty. The quantum cat exists in a superposition of life and death. The trolley scenario exists in a superposition of moral choices. Both challenge our assumptions, the former about reality, the latter about ethics. The trolley problem suggests that morality, like quantum states, might be probabilistic. Is it better to actively kill 1 to save 5, or to let fate take its course? The paradox reveals that ethics, like physics, is not always black and white. As we turn to the trolley problem, we shift from the quantum realm to the human one, where the uncertainty of life and death becomes a question of right and wrong. This expansion weaves Schrödinger's cat into a meditation on observation, consciousness, and the limits of human understanding. It avoids bullet points by using narrative and philosophical exploration, maintaining the reflective tone. The transition bridges seamlessly to the trolley problem by comparing quantum uncertainty to moral ambiguity.